Solving using matrices. So matrix is so it's plural for matrix, but it's a bracket that we're going to use. So we say matrices because it's a multiple aspects of a matrix. So we're going to start by doing this, and we're looking at now, solving with matrices becomes more effective when we're dealing with 3 variables and 3 equations. And you might wonder, well, why would we do that? Because if we do graphing like you've always done graphing in the past, it's like this. But what you don't realize is that we live in a 3-dimensional world. So if I draw this arrow coming out, that's the Z direction. This is my X direction. This is my Y direction. For anybody that does any kind of AutoCAD or programming in the 3-dimensional, or you start working in architecture, you're going to have to work in a 3-dimensional world because we exist in one. So you're going to have an X, a Y, and a Z axis. So now what we're looking at is where do these 3, if they do, where do these 3 equations intersect in this 3-dimensional world? And then later on, it'll be doing some where do the 2 planes intersect in the 3-dimensional world. But that's why we do what we do when we're doing matrices. And what I do with the matrices is I'm actually going to get rid of the X. That's a Y, by the way, or it should be. That's a Y. X, Y, and Z, X, Y, and Z, X, Y, and Z. If I have them all in standard form, which is X, then Y, then Z, and then my numbers on the right side of the equal sign, I'm going to draw a matrix that actually has all of these numbers in it, but no variables, and it looks like that. All right, so you can see, because I left the little equations at the top there, that the coefficient of the X is 1, the coefficient of and that should be a Y, I just copied it from the other one, is 2, the Z is 1, the coefficient of this X is -2, and I wrote them in colors so you could see which ones they all correspond to. So that's the first step in doing matrices. My goal with a matrice is I want my final matrix to be like this, and this is 1, these will be 2 numbers, this will be 0, this will be 1, and that'll be a number, this will be 0, this will be 0, this will be 1. And I'll show you how we're going to do that, because when I do that, and when I get there, you'll go, oh, got it, now that, okay, since that's a 1, and then we're actually going to double back and use some substitution to find the other 3 values. So then, after we have this, what I'm going to be looking at again is how do I get the first coefficient to be 1? Now, what we've done and what I'll say is there's a lot of things I can do. It doesn't matter the order that these are put into this, but right now it works. So, I mean, I could have put this as the bottom row. Could have put the red as the middle row and blue as the top row. So you can move the order, like you can move them from row to row. It doesn't really matter. It's just rewriting the equation. All right. But what I did is I started with an equation up here that already has 1, so I've already met my first goal. The coefficient of that first one is 1, so I'm done. If this had been my top row equation, I would have just switched it for one of the other ones and made it not the top row. So eventually what you'll see is we're eventually going to move, well, I'll get there. So then here is my matrix with just the numbers in it. All right, there's no reason why that's missing. There we go. And what I'm going to do and what I'm thinking is, how can I make this a 0 using either of these 2 equations? And when we've done linear combinations in the past, what I'm going to do, you're going, oh, that makes sense. I hope anyways. So if I add -2 to 1, I don't get 0. But if I take this number and double it and add it to -2, it will be 0. But then I take this number and double it and add it to the -1. I take this number and double it and add it to the 2, and this number and double it and add it to the 5. So really what I'm doing is I'm taking this down here, I'm going to multiply it by 2, so 2 times 1. I'm going to take this number down here, and I'm going to go 2 times 2. I'm going to take this number down here, and I'm going to go 2 times 1. This was a negative, so it's going to mean 2 minus 2. This was a negative, so it's going to be 4 minus 1. This is a positive, so you just got to remember it's plus in there. So those coefficients would then become 0, 3, because it's 4 minus 1, and then 2 plus 2 is 4, and I can't forget the last one down here, so that'll be 2 times 2. When we did linear combinations in the past, it would have been like, well, I'm going to take the whole first equation, going to multiply it by 2, and then I'm going to add the 2 equations together. It's the same idea. We just have a better way of keeping it organized here, and I'm not losing track of all my X's and my Y's and my Z's. And when I do, let's go back here. So then for the the bottom equation, I want this to be 0. How do I get this to be 0 using one of these two equations? I'm actually going to use this top equation again, and I'm going to take that 1, bring it down here, and I'm going to go multiply it by -1. So -1 times 1. So -1 times 1 is -1, plus 1 is 0, so that first number is also 0. I'm going to bring this 2 down here. Again, it's getting kind of sloppy, and I'm going to multiply that by -1 times 2. That'll be plus that 3. And then bring this number down, -1 times 1. Just remember, 2 times this coefficient, 2 times that coefficient, 2 times this coefficient, 2 times that number. So this number will be the same for all the parts in that row. Down here, the number I chose was -1. The reason why I chose it is so that -1 plus 1 down here, that'll give me 0 there. Because again, remember, my goal is for this to be 0 and this to be 0. And then on my next step after I do that, I'll want to make sure that this is a 1, this is a 1, and that's a 1, and that this will be 0, but I'm not there yet. I get this. Oh, I forgot to. So then I get to here, and you see I just rewrote it again. It's the exact same thing as what I wrote before, but now you can see when I do this, 2 times 1 minus 2, that will give me, let's see, that's my red row, 0. In the middle here, I'll 4 minus 1, that will give me a 3. 2 plus 2, that will give me a 4. And I forgot to write this down here, so this would be 2 times 2. So that will give me 9. In the bottom, I'll have 0. -2 plus 3 is 1. And then -1 minus 2 is -3. And then positive 8. Correct myself there, sorry about that. That's not 8. Because I bring this 2 came down times -1. So it's -1 times 2, which is then -10. 10, how did I get 10? So now this is what the matrix then becomes when I start to simplify those numbers together. Again, my goal was 1. I want this to be a 1 and then that to be a 1. But as I said at the beginning, I could reorder these any way I want. This one's already a 1 in the second spot. So I'm going to actually take this row and flip-flop these two rows, exchange them one for the other, and it becomes like that. So I moved my blue line up. So now I've got 1, 1. I still need this to be a 0. So using the process we had before, then I'm going to multiply the second row by something to add to the third row. What do I multiply this by that's going to make this 0? -3. So when I do that, it's going to be -3 times 1. -3 times 1. Bring that down. Will be -3 plus 3. -3 times -3 to here. So that'll be 9 plus 4. -3 times -10 is -30. Plus, oh, it's positive 30 because it was negative. Keeping track of your negatives, right? Because I multiplied everything here, this whole row, I multiplied by -3. All right, so again, all we're thinking distributive property, -3 times here, -3 times there, -3 times there. Gives me this matrix now. 1, 1, and I'm almost to a 1. All right, I wanted these all to be zeros. How do I make this 13 a 1? When I just look at that row only, using multiplying, adding, dividing, all sorts of things, if I divide 13 by 13, that will give me 1. But whatever I do to one thing, I have to do to all things. And 39 divided by 13 is 3. So what does that mean at the end? It means that this equation here still has x, y, z. So it's 1x plus 2y plus 1z. Now I didn't write the 1, but it's there. Equals 2. Second equation, there is no x. It's gone. 1y minus 3z equals, that's the equals, -10. And then my last equation would be 1z equals 3. Now I can find y. Take this 3, put it right in there. So it's going to get a little bit, slide that up. So I'm going to take this 3, plug it right in there for z. I'll have y minus 3 times 3, 9, equals negative 10. Y equals negative 1. All right, because I added 9, negative 10 plus 9. So y is negative 1. The z was 3. Take my last equation, x plus 2 times y, negative 1, plus z, 3, equals 2. As I said in the past, I always cross my z's. I don't cross my 2's because they look very similar. That's a 2, that's a z. But I took this equation, x, down here, x, 2y, 2 times negative 1, because I just found that for the y. Z is 3. And then, just going to, do my math on that one. X minus 2 plus 3 equals 2. Something I've seen people do, and don't get in the habit of doing this. I'm going to show it because it's wrong, and then I'm going to get rid of it. People are going to go, oh, plus 3 minus, plus 2 minus 3. You can do that only if you do it to the other side as well. What I would recommend you do instead is just simplify this left into x plus 1 equals 2. Negative 2 plus 3 is positive 1. Simplify one side, then move things over. Try not to move things over in multiple steps. Tend to make mistakes when you do it. X equals 1. What number plus 1 is 2? X is 1. Now, ultimately, in the very end, I would go back and find out if I plugged this in for x, for z, this in for y, and this in for x, back into all those 3 original equations, I should get the final equals that was indicated in that original problem. So there's your quick intro, and I really mean quick intro, on how to use matrices. Matrices actually are much more powerful. If you decide to pursue more in this area, you'll have a lot more exposure to matrices. And find out that technology tools can help us then do bigger matrices when you're dealing with things that are more than 3 dimensions.